Here I'm going to go over the answers to classwork 2. So we start with a question on proving that indifference curves cannot cross, and it'll be a proof by contradiction. So I say consider two indifference curves, I1 and I2, and let's go ahead and draw those curves. So it's going to be the way a proof by contradiction works is that we'll assume that indifference curves can cross, and then we're going to come to a contradiction, proving that they cannot. So let's draw two indifference curves, I1 and I2, that are crossing. So that it's going to look like this. We have I1 and we have I2, something like that. So it says bundle A is on I1 and not on I2. So this is bundle A. And bundle C is on I2 and not I1. So here's C. The two indifference curves intersect at bundle B. So bundle B is the intersection point right here. So bundle B is both, and what I'm looking for here is for you to say it's both on I1 and on I2. It's on both indifference curves. Because A and B are both on I1, we know that you're indifferent between A and B. And because B and C are both on, they're both on I2, right? That's what I'm looking at for this blank. They're both on I2. We know that you're indifferent between B and C. So I'm looking for B, squiggle, C there. Transitivity indicates that we should therefore expect, so we have A, we're indifferent between A and B, and that we're indifferent between B and C. Transitivity therefore should say that we're indifferent between A and C. So I'm looking for A, squiggle, C. But this is a contradiction because A is on I1, C is not, and I1 contains all the bundles X such that we're indifferent between A and X. If we're indifferent between A and C, C should be on I1, but it's not. Therefore, the two indifference curves can never intersect. All right, so that's part A there. Let's move on to part B. Okay, part B says perfect substitutes are goods that can always be used interchangeably. For instance, if I'm just as happy using butter or margarine to make cookies, then butter or margarine are perfect substitutes for me. Suppose I need a cup of butter or margarine to make a batch of cookies, and for example, 0.93 cups to make 0.93 batches of cookies. Assume I'd always prefer to be able to make more cookies than less. I'm indifferent between having 0.25 cups of margarine and 0.25 cups of butter to having 0.5 cups of margarine, and right here I'm looking for 0 cups of butter. Because I have half a cup, I add them up, I have half a cup of butter-like substance, so I'd be indifferent between having a half a cup of butter-like substance. Doesn't matter where that's coming from. So I'm looking for 0 there. Sketch my indifference curves for butter or margarine. So I'm going to use the indifference curves that this kind of thing. Let me have margarine. Doesn't matter which you put which way. Margarine here and butter here. And I say I'm indifferent between having 0.25 cups of margarine and 0.25 cups of butter. Let's put that here. To having half a cup of margarine and 0 cups of butter. So that would be over here. Half a cup of margarine and 0 cups of butter. And then we can connect the dots, but you can also imagine, to kind of fill in this indifference curve, I would also be indifferent to having 0.5 cups of butter and 0 cups of margarine, right, which would be up here. And then so I'd always prefer to be able to make more cookies than less. So we could also draw indifference curves out here. Let's consider this would mean half a cup of butter, half a cup of margarine. So I could make one batch of cookies because I have 1 cup total. And then I'd be indifferent between that and having 1 cup of margarine or 1 cup of butter. Should be up here. So should be parallel to the indifference curve that I just drew. Does that look? I think that looks about parallel. Let's check. Not quite. Try again. Okay, that's a little bit better. So my indifference curves are gonna all look like this, where I'm happier the further up, up to the northeast that I go. So the last part says, compare your sketch to the standard C-shape indifference curves, where the more of one good you have, the more willing you give it up. The more willing you are to give it up to get more of the other good. So what I'm talking about there is these indifference curves that look like this, where when we're way out here, we have a lot of one good and not much of the other. We're willing to give up, let's see, if we look at the marginal rate of substitution here, we could give up, or how much of this good X would we be willing to give up to get just a little bit more of Y? It would be a lot, right? We're willing to give up this much of X to get just a little more Y because we have so much of X. So that's the property of diminishing marginal rates of substitution. Perfect substitutes, though, do not have this quality. So I'm just looking for you to say no here. Perfect substitutes don't have this sloping down as you get more and more margarine, because you're just as happy having margarine as you are butter. So the marginal rate of substitution is perfectly constant across any amount of margarine or any amount of butter. That's what makes perfect substitutes, the indifference curves for perfect substitutes, so interesting. They have constant marginal rates of substitution. All right, let's go on to the next problem. I want pink.